the y-intercepts. And the new stuff that we're going to do with them is we're going to find things that are called asymptotes. Some rational functions will have vertical asymptotes. Some rational functions will have horizontal asymptotes. And some may have both of those. And there are also rational functions that might have things called slant asymptotes. And we're going to look at how to find those starting today. So let's start with our first rational function. It is going to be 6x minus 2. So here's our function, f of x equals 6x minus 2 divided by, I can't see that well. This is how some people tell this. 2x minus 5 divided by 2x minus 2. 2x minus 5. Negative, okay. 7x minus 2. Let's start with things that we know how to find. X-intercepts. How do we find x-intercepts? In general, how do we find the x-intercept of anything? Set y equal to 0 and solve. So that would be, our f of x here would be 0. So we'd have 0 equals 6x minus 2 divided by negative 2x minus 5 times 7x minus 2. How do I solve that? Oh, come on, guys. It's just a fraction. Fractions aren't so bad. What would you like to do? By the bottom part to put it on the top? Okay, you don't really want to put this up here though, right? No, not really. Remember, this is 0 over 1. When you've got a fraction equal to a fraction, what can you do? Cross multiply. Over an equal sign, you can cross multiply. When I cross multiply this 1 times that 6x minus 2, what do I get? 6x minus 2. When I cross multiply this 0 by that negative 2x minus 5 times 7x minus 2, what do I get? 0, because 0 times anything is 0. So Brenda had kind of the right idea. You do want to multiply both. You essentially could multiply both sides of your equation by the denominator. When you multiply the left side, you end up with 0. When you multiply the right side, the denominators cancel, and you end up with the numerator, and that's where we are here. We can solve this. Yes? You're all going, okay. How? Add 2. So I get 6x equals 2. And then what? Divide by 6, so x equals 1/3. Am I done? No, why not? X-intercepts are points. So this would be 1/3, comma, 0. Now, because we are dealing with a rational function, we need to do something before we say, okay, that's absolutely positively my answer. And here is what we need to do. We need to plug 1/3 in for x in the denominator. Why do we need to do that? Yeah, because if I plug it in here and I get 0 out, then there's no way that point is even in the domain of my function. And so although I was able to get it out when I multiplied, set it equal to 0 and did my multiplication, I might have lost the fact that it was something that would make my denominator 0. So when I plug 1/3 in here, what do I get? Approximately. Is it 0? How's that for the question? Do I get 0 when I plug 1/3 into this piece? No, because I have negative 2/3 minus 5. There's no way that's going to be 0. Do I get 0 when I plug 1/3 into this piece? No. So that means this one is fine. That will be my x-intercept. If I were to have gotten 0 in either of these pieces, then this would not have been an x-intercept, and I would have had to say that there were none in this function. What about finding y-intercepts? I'll put parentheses because there may or and solve. Okay, so I'll have f of 0 equals 6 times 0 minus 2 divided by negative 2 times 0 minus 5 and 7 times 0 minus 2. So what do I have in the numerator? What number do I get from my numerator? Negative 2. What number do I get in this piece of my denominator? Negative 5. And in this piece of my denominator? Negative 2. So altogether that comes out to be negative 2 over positive 10, which is the same thing as negative 1/5. Am I done? No. Okay, what do I need to do now?
The point, so 0.
0, comma, negative 1/5. Y-intercepts I don't have to worry about, because I plugged the number in for x. So if I get out a y-intercept, then that means I have one. It's not like where I was solving for x and I might have found out that something in my denominator, come up with something that would make my denominator 0. Now for the new stuff. Vertical asymptotes. Anybody know what a vertical asymptote is? Yes? What is it?
That's where the graph approaches the line, doesn't touch it.
Approaches what kind of line?
Imaginary. Where are you approaching?
Not imaginary.
Approaches up
It
there.
approaches it, but it doesn't actually touch it, it just keeps going.
Not always. What kind of line are we talking about approaching?
Vertical line.
Vertical line. So an asymptote is when the graph approaches a vertical line and either heads up to infinity or down to negative infinity. And then it's basically misses that line altogether, and then your graph can continue. Usually our polynomial rational function graphs will continue on the other side of that line, either coming down from infinity or coming up from negative infinity. How do we find vertical asymptotes? Anybody know? Nope. Because nowadays your calculators, most of you have 84s, they won't graph them nicely for you. Your 83s used to actually draw them in for you when you graphed. It was really nice. You could always pick them out. But the 84s don't draw them in. It has to do with the denominator, and it's related to the domain. Vertical asymptotes occur when a value of x makes the denominator equal to 0. But it does not make the numerator equal to 0. We'll talk about what that is once we get to 1. So in order to find my vertical asymptotes, I need to set my denominator equal to 0. So negative 2x plus u minus 5 times 7x minus 2 equals 0. This will give me negative 2x minus 5 equals 0. And 7x minus 2 equals 0. Let's work with this one. Negative 2x equals positive 5, so x equals negative 5 halves. And then on this one, we would have 7x equals 2, so x equals 2 sevenths.